Computing diameter lines of a 3D spherical mask. Background. For an algorithm I'm working on, I currently use a 3D sphere as binary mask, with an n(x) and xn array having voxels and a sphere of radius n/2 as true. Further processing does computation for each voxel set as true. It proved computationally intensive for my specific task as n grew large equals O(n cubed), so I now want to reduce my binary mask to a subsample of lines radiating from array center within radius. Objective. I want a 3D binary mask of the lines in gray in the image. To have a bit of control over the number of voxels, I would have a parameter, say L, regulating the number of lines sampled in each 2D circle, and maybe a second one, K, for the number of Z rotation. Would I try? I am using numpy and scipy, and I thought that I could use the scipy.endimage.interpolation.rotate method to rotate a single line around on a plane, then use a complete 2D mask to rotate around the Z-axis. This proved difficult, as interpolate uses some deep magic regarding splines that discard my true values on rotation. I am thinking that I could compute mathematically which voxels should be set to true by following some line equations, but I'm at a loss to find them. Any idea how to get there? Update, solution. Thanks to Chvalden who helped me think this through and gave code samples, I have this. Max is radius of sphere, n_theta and n_phi the number of polar and azimuthal lines to use. With the spherical underscore to underscore Cartesian from this code sample. Which gives me this, with max equals 50 and n_theta equals n_phi equals 8. Center area tuned out of my function by choice.
I propose to change the coordinate system to spherical coordinates. Thus, you will choose your 2D circle by an azimuthal angle, and a line then is defined by additionally choosing a polar angle. The variable along the line is then just the radius, and you can use numpy.linspace to discretize it. Doing so might also save time during calculation. You can switch your coordinate system anytime by using the bijective relation which is implemented for example here or here.
If you want to see more, please consider subscribing.